We've got more special right triangles today. And again, they're really not that special, but we call them that. Today, instead of doing triangles that have degrees 45, 45, and 90, we're doing ones that have 30 degrees, 60 degrees, and 90 degrees. Okay, so it's the same exact concept as last time, except they're different triangles, so there's different shortcuts and rules that are going on. So we're going to start the same way we did with the last lesson, and we're going to do 2 review problems with Pythagorean theorem, and we're going to see if we can notice the pattern to kind of like figure out how to avoid Pythagorean theorem on the rest of these problems. So if you look at number 1, I see that the angles are 30 degrees, 60 degrees, and 90 degrees. That means that these shortcuts will apply. Okay, those angles have got to be there. I want to use Pythagorean theorem, so 12 is the hypotenuse that goes by itself. So I'm looking at x squared plus 6 squared equals 12 squared. Okay, so that'd be x squared plus 36 equals 144. We should be able to solve this pretty easily without a whole lot of help. When you subtract the 36 over, you get 108. And they do want me to leave my answer in simplest radical form. So when I square root, I want to do factor trees. And let's see, if you're stuck on what goes into 108, well, you know it's divisible by 2, so you could start there. Let's see, I know that 9 goes into 54. So that's 3 and 3, and 3 and 2. A lot of review here. Ooh, those are super tiny, but that's 3 and 2 and 3 and 3. So when you rewrite this, I see a pair of 2's and a pair of 3's. So 2 times 3 would come out making it 6, and that 3 stays underneath. Okay, so x is 6 radical 3. On the next one here, same idea, so I'm going to set it up, x squared plus, I'm going to use parentheses, 5 radical 3 squared equals 10 squared. When you square 5 radical 3, you have to times it by itself, so that would be x squared plus, well that would be 25 radical 9, which is really, you guys, just 25 times square root of 9 is 3. So 75 is what that equals. Equals 10 squared is 100. Okay, when I subtract over the 75, I get x squared equals 25. Awesome, which that's a perfect square. So I get 5 for my x value. All right, let's see if we can notice any patterns. So the legs are no longer the same like they were in the 45, 45, 90s, but these 3 sides are related. So notice that in your 30, 60, 90 triangle, one of the legs is going to be longer than the other leg. So across from the shortest, or the smallest angle I should say, across from the smallest angle is the shortest side. So number 1, the shortest side would be 6. Over here, let's see, that's 60, 90, so this is 30. Across from that angle, that's the shortest side. Okay, so you're going to have 2 different legs. One's going to be called the short leg, one's going to be called the long leg. So if you kind of look here, like the short leg is just like a plain number in these. The long leg, they just take the short leg and they put a radical 3 on it. And it looks like if they take the short leg and double it, that's the hypotenuse. Okay, so it's not as like simple as 45, 45, 90s, but there is a pattern. So this theorem here is just a shortcut, which we all love shortcuts. I don't want to do Pythagorean theorem every time. It's just too much work. Okay, and sometimes I don't even have enough information to do Pythagorean theorem. So I want to use this shortcut. Now, like I said, sometimes, or in all of these, one of the legs is shorter than the other. So here's a 30 degree. Across from that, that's the short leg. So I'm going to call that leg just x. And I'm going to label it short leg. Across from the 60, that's the long leg. Okay, bigger angle, it's going to be a bigger side. This one, if you take the short leg, x, and you put a radical 3 on it, that's the shortcut for always finding the long leg. And like we said, if you take the short leg and you double it, that's always the hypotenuse. So we'll call that 2x. Now, just like last time I said, oh, hypotenuse equals leg times radical 2, I'm going to come up with like 2 little equations here that are going to help you with these triangles. And they all reference the short leg. Okay, so this is big what you need to know. The short leg times 2 equals the hypotenuse. And then I'm going to say short leg times radical 3 equals the long leg. These are the 2 things that I'm going to use when I solve all these problems. I might have to go backwards on some of them, but this is what I'm going to reference. Okay, let's put it into play. Finding the lengths of the legs. So let's see, there's the 60, so that's the 30. Across from the 30, this is the short leg right here. And it's x. Okay, notice the only piece they gave me was the hypotenuse. So they gave me this. And I should be able to look at this one pretty easily. I know that 2 times the short leg, so if I want to write this out, I can. 2 times the short leg equals the hypotenuse. So 2 times x equals 8. I can solve that. Divide by 2. So the short leg is 4. I know then to get the longer leg across from the 60, if I do the short leg 4 times radical 3, that's the long leg. Do not overthink it, you guys. Why would just be 4 radical 3? For the next one, same thing, across from the 30, that's the short leg. So I use that one for sure. I want to find that first, and I'm given the hypotenuse. So I'm going to use this first shortcut again. The short leg, which is x, times 2, equals the hypotenuse, which is 12. So when I divide that by 2, I get the short leg is 6. And then to get the long leg across from 60, which is y, if I do 6 times radical 3, that's my long leg. Okay, not too bad so far. On the back, whoa, this copied awful, you guys. Complete the triangle, would you? That looks weird. All right, so these are the last 2 examples, and obviously like radicals kind of make these a little bit more complicated than the first 2. So it's still the same ideas though, and I kind of cheated a little bit and put my little shortcuts on a sticky note here. They're the same ones that were right here. I definitely want to identify the short leg first because that's what I reference for all of these. So there's the 30, there's the 60. Across from the 30, this y is the short leg. Okay, so y is the short leg. This time, instead of being given the hypotenuse, I'm given the long leg. So I need to look to this second shortcut first and use it. I know if I do the short leg, which is y, times radical 3, I get the long leg, which is 5. Okay, so I just need to solve this by dividing by radical 3. And here's where rationalizing the denominator comes back yet again. You got to multiply by radical 3 over radical 3. On top, that would be 5 radical 3. And on the bottom, the radicals cancel, and it's just 3. Okay, so there's my y value. It's not the nicest number, but there it is. That's the short leg. I need the hypotenuse still, so I'm going to do the short leg times 2 to give me the hypotenuse. So short leg is 5 radical 3 over 3. Okay, to multiply that by 2, that'll give me the hypotenuse, which is x. Okay, this is really gross, but to multiply this, you ignore the radical. That's not involved in this. So to do that, you really just think of this as a fraction, like 2 over 1. Honestly, you guys, the only two numbers that you have to multiply are the 5 and the 2. So I would make that 10 radical 3. 3 times 1 on the bottom, then just stay 3 on the bottom. That's my hypotenuse. Gross numbers. All right, last one. Same idea. I want to locate the short leg. So there's the 30 if that's the 60. This time they give me the short leg as radical 6. So okay, that's good. Let's find the hypotenuse, which is y first. So the short leg radical 6 times 2 equals the hypotenuse, which is y. You cannot multiply these and get 12 somehow. A radical number and a plane number cannot be combined, so you just press them against each other, and they'll write the 2 first. They'll say 2 radical 6 is y. Okay. Now I need to get the long leg, so use my second shortcut. The short leg, radical 6, times radical 3 equals the long leg, which is x. I can multiply these because they're both sitting under a radical. So 6 times 3, this would be radical 18. And they definitely will expect you to factor tree that down. So I would say x equals 3 radical 2. All right, that's special right triangles. Aren't you glad you were not the one to discover all of this?